Okay. Hello everyone, and thank you very much for being here for my presentation. I'd like to start off by introducing myself. So my name is Tiejun Chen. You can call me Tiejun. I'm staff 2 engineer and one technical leader from VMware office of the CTO. So basically in our team, I'm working on several different research and innovations, but also have some personal exploration. I just always get myself involved too much from low-level technology and to the automotive system, robots, and even machine learning, edge computing, something like that. So before I joined VMware, I also worked at some company like VMworld system for VMworld Linux and virtualization development. And even I also worked at Intel OSTC, Open Source Technology Center. Basically, our team was trying to enable some new hardware features to that open source project, like KVM, Zen, and Qmute, something like that. Okay. So back here, today I'm going to talk about something about virtualization on embedded system. That's my project, E2S2Xi. It's like the abbreviation of embedded system, EXI. I believe this is your interest too. I guess around this VMworld, you get more information about virtualization in data center. Now let's talk about something new. Okay. Sorry, I have enough time to reflect my slide to that formal VMworld template, but I need to make this clearer. So essentially, this is my personal exploration. So far, there's not a roadmap or commitment from VMware, but I'm working toward that. So let's go through the agenda. I think there are a few parts. First of all, I think I need to give you some background on virtualization and embedded system, and then let me introduce my project. And I hope I have some time to show my demo. So virtualization, I think there are many definitions to virtualization technology. Some people say container and Docker. Some people say VM, traditional VM, and hypervisor. Here, let's focus on and limited to that hardware-assisted virtualization on that hypervisor and that VM. That means we need some CPU feature like Intel VTX or that AMD SVM. But in this, now we talk about embedded system. In this area, you probably see that ARM or even MIPS and PowerPC, and also that RISC-V. Fortunately, this CPU processor have the similar virtualization extension. That means we can enable virtualization to this platform. And how can we classify the virtualization? You probably know the type 1, type 2, and even the type 3 hypervisor. Type 1 hypervisor, just like hypervisor and virtual machine monitor, is running on top of that physical platform. Sometimes we call it that environmental hypervisor. Type 2 means the hypervisor running on the top of host OS. Think about our workstation. We call it the host hypervisor. I'm not sure if you have heard the type 0 hypervisor. Essentially, it's based on the microkernel. Microkernel means that we just keep those necessary components in that kernel, like a scheduler, but put other, like the device driver, out that microkernel, just work as a service. It's very lightweight. Another way I classify virtualization technology is that full virtualization and peri-virtualization. Full virtualization, that means that you can run modified OS on that hypervisor, on the virtual machine monitor. Peri-virtualization, that means sometimes you want to enable that hypervisor awareness into that OS to achieve that performance, especially the I/O performance. So why we need that virtualization on embedded system? There's some benefit right here from cost. So typically, we can use that one powerful multiple platform to consolidate that hardware and software consolidation. Think about it, we can run one general open system, another instance run that RTOS real-time system, and even can run some legacy operation code, because back to that IoT, the many legacy code should be deployed right there. But we have a VM, right? This can help us speed up the time to market. Security, hypervisor always can provide a strong isolation between the safety critical environment and to the non-safety critical environment. And the mixed credit system, that means protecting safety and security parts of the device from other parts of the device. Especially in industrial IoT, in automotive systems, there are many rigorous specifications standards to that these devices. Think about this, without virtualization, you have two applications. They have to meet the different levels. But when put them in this software box, that means this two application can interfere with each other. So they must be certified to the highest level of the application. So virtualization can provide that secure separation. It aims to eliminate such that interference. Multi-tenancy and flexibility, I think just like what we are doing on cloud in data center. But now we also want to build a software-defined edge computing and software edge device services. So we also need a virtualization build as a foundation. Okay, actually there are many use cases in the product environment, like a Chinese communication system, maybe NFV, and even a value cloud, you heard that. Avionic system, and even that industry IoT, again, need that workload consolidation. Automotive, I love automotive. At the very beginning, I mentioned that. So in the future, in the near future, the automotive industry will always provide a vehicle running that multiple advanced function, even as a self-drive function. So that means in this requirement, in this environment, the vehicle hardware and software components grows significantly with these functions. So each time its function is added, that means additional sensor and keyboard and ECU, electronic control unit, are added to the vehicle. That increases that space, weight, power consumption. This brings have some big impact on that cost, and they also have some security, safety issue, and connectivity issue. So the number of ECUs and that connective capacity can be reduced by replacing them with that virtual instance in that one ECU. And meantime, again, in terms of that automotive system, they have that one specification at automotive safety integrity level. That's 3 levels. We can deploy the different applications to the different domains, like in vehicle infotainment, in vehicle control system, and even that powertrain, something like that. Okay, sorry. Actually, you can see the virtualization technology is really making into the embedded system. You can see some existing solutions. Some are based on the open source community hypervisor, KVM, and then even in recent years, maybe you know that Icon hypervisor was released by Intel. And even you can see some commercial solution. QX is targeted to the industrial IoT, especially for the automotive system. Also, there's some market right there. On the right side, just look at the right side, there's one picture of pick up from one that reports that global embedded hypervisor software market. It's a sample page because this report is not free, but it still can have a rough number. By the end of the 2025, around 22 or 23 million dollars in this market about embedded system hypervisor. Okay, so we can enable virtualization because I talk about the embedded system CPU processor can support that. We have that market, we have the benefit right there. So I think VMware should be there. Talk about VMware, we have our EXI. EXI is a market proven that enterprise grade that hypervisor, but in the data center, just like that. I think we can start from there. So in this project, Embedded System ESXi, I hope I can build that foundational software-defined edge computing system by means of our virtualization technology, especially ESXi. I hope this can support x80 and ARM, even that next year on RISC-V, and also provide some lightweight on the OS to carry out that service. And put them together, we can provide that foundation of software-defined embedded system computer service solution. But the age set them down because ESXi is designed for that power, data center physical server. It's very heavy, so we are facing some challenges. The first one, this device just like the resource constraint. So we need to reduce its image size. We need to reduce the memory overhead. So some of it we can do, like we can reduce the supported number of the physical CPU and vCPU and VM. They also can decouple some service like vSAN and even the DCUI. We don't need that in this embedded system. And also I modify some that heap memory reservation to reduce that memory. And either with some way I can reduce the memory overhead. So another challenge about the device, VMware for that cloud foundation, that means we just need to consider the CPU virtualization, memory, storage virtualization, and network storage virtualization. So you know we have that PVSCSI, we have VMware 3. But this device have a variety of that interfaces like that Wi-Fi, LTE, 4G, and Bluetooth, and even Zigbee, Vivo, and even some industry protocol like IS-485 and even Modbus, something like that. How can we enable this device? Maybe one way is straightforward. We need to write down this device driver. But that means you need to write the device driver, you need to maintain the device driver, you have to update the driver. I think it's a terrible nightmare. I don't like that. So instead, I build one lightweight that super user world was 0, where I deploy that links. Most of these interfaces are based on USB bus or some PCIe bus. So that means we can pass through this controller to this super world 0. And then I introduced one that common edge computing service framework that EdgeX Foundry. It's hosted by Linux Foundation. It essentially is that containerized that microservice architecture. I just deployed one that device service layer in this super world 0, but deploy other service layer to the different VM. So at this point, we can share this device with different VM. Another bonus is that you can build edge computing service on this solution. But the Wi-Fi and IoT is different. I still pass through this controller to that super world 0, but I build some internet service and populate the insert port to make sure on every internet port, if they connect to that vSwitch, they can get access to the external internet. I will have demo show no, you can use the Wi-Fi to get access to that EXI. So another about the real time. Now, typically in many use cases, not all use cases, we run this essential system on that safety critical environment like oil, the gas, drilling distribution, and even public safety transportation, something like that. You need to meet real time. You meet that hard real time requirement. But unfortunately, our VM kernel cannot be converted to that fully preempted kernel. Okay, so here I'm trying to build that AMP framework. Just like we isolate some physical CPU and as well some memory to this another domain. I call that the safety critical domain. And EXI just load that native RTOS image to this domain. So this can help reduce that context switch between the VM or that host, just like it runs at top of that environmental environment. So another approach, recently I'm talking about some people, maybe we can build multiple VM kernel. This new VM kernel is built at macro real-time of system where we have some real-time schedulers like EDF, something like that. I'm not sure you have know that one open source solution is based on that Linux, on that Dynamic. They also have a similar idea, similar to a kernel. So once the interrupt is triggered, or this interrupt is delivered to that RT kernel, then we will take responsible for the scheduling that real-time RTOS. Once we get this real-time workload done, and then we pass through the normal VM kernel. So now about security. We need to figure out something to improve the security. So typically, we have a virtualization provide isolation between VM. That's not enough. Sometimes you want to run that instance, your application, or even a container in the one VM, right? How to protect them in the one VM. So new problem there, one VM just has one EP table. EP table is a feature on this can help you convert that guest with physical address to a host physical address. Now we assign multiple EP tables to this VM, one given VM. According to different requirements, we can assign EP table different container. We can isolate this container just in one VM, provide strong isolation protection. Okay, another we have EXI, but also need to figure out if we can build some lightweight OS. We still not resource constrained. Here, let's start from PhotonOS. PhotonOS is our Linux distribution, but we need to figure out some way to make sure PhotonOS is a BSP level PhotonOS. Support different profile like a standard and real time, even like what I ever did in the vendor real. We have 3 profile. Also support cross compile. You want to build something for like ARM or RISC-V or something like that. And we also introduced some lightweight OS like Unikernel and Linkskit and CRX, something like that. Although no, you can say we have basically we have this EXI. They can run on this resource consumed device. But this is not our final goal. I hope we can build a software-defined edge computing framework. So I introduced one that manager in this SuperWorld 0. And also I divided this service into two groups. One is system service. You want to provision, you want to upgrade, you want to manage the system itself. Another service is a user-defined service. What kind of function you want to run this system? Like maybe you want firewall, router, just to give you an example. So this can help you build that serverless capability with this lightweight vessel I mentioned just-in-time service. Okay, another question is we need to consider how to give that delivery in the production environment. We need this automotive builder tool. You just tell me what kind of delivery you want to build. You need to consider that hardware platform, what kind of that profile to the EXI, what kind of profile to that application, and then we can build that delivery, just install that into the final product. Okay, this is something what I have done as we know. Okay, I built this my embedded system EXI on that 6.2, and also have to modify some code to make sure that EXI can show that a very low resolution display. It's one thing, and also reduce the image size about 130 megabytes. The memory overhead is reduced to less than 900 megabytes. And also build that UI to manage this EX holder in this system. Because it's different from cloud, we cannot use that vCenter to manage this device. vCenter in the cloud, that EX host, these devices are distributed to remote locations. They are not in the same network. We cannot register this device to the vCenter directly. So instead, I build one lightweight that manager in the cloud, a lightweight agent in that SuperWorld 0. Okay, and then build some communication between this agent. Later, I show the demo. I can use one that manager in that VMware Cloud in the public to upgrade that EXI in the platform. For real time, for a limited time, just provide strong isolation. Maybe I can figure some time to step forward. But that solution is get approved by the patent. Okay, now let's show me some demo. Okay. I don't know. Okay. This demo is based on this platform, app platform. It's an x80 based platform. Enabled our EXI in the platform and also enable Wi-Fi here. Also enabled that edge computing, machine learning inference. It's not clear. You can see that one below. That device is that Intel VPU. Okay. You can see on this that small display plugged into this device. This another display is connected to this platform as well. This small display just shows the information about the EXI itself. Another display will show that machine learning inference result. How to play that? Yeah. I record the video in my home. Now there are 3 VM in this small platform. One is that SuperWorld 0. Another 2 VM help us build that machine learning inference. One is connect that video streaming from a remote IP that camera. Another VM take responsibility for that machine learning inference based on Intel VPU and OpenVINO, just like that. But everything you can manage that through Wi-Fi. You use that on vSphere current or something. How to? Okay, another one is about this device. Similar thing. This device can plug into this display directly with that HDMI. will set up my that Wi-Fi environment in my home, and then can use my that laptop to use that vSphere client to log into that EX host to manage that. I'll show this one. Even you can use yourself to log in Wi-Fi to manage this EX host. So you still use that vSphere client. Last one is about, as I mentioned, I can remote upgrade EXi on this platform. This web UI is very simple. One is in this device, another one in the VMC cloud that has a public IP address. Web UI in this agent, actually they can manage the local, it can connect many that devices in the one local vessel to manage that. What do you need to do? Just upload which new EX version should be uploaded right there and send out that command. You can see ESXi command successful created upgrade command created. In another screen, you can see when I connected to this device that EXI 6.5 will be shut down and then reboot, and you can see EX 6.7 is running, and all VM just back up. Okay. I think this is something I was trying to talk about today. So, do you have any question? Or? Not Raspberry Pi. Both are x80 based platform. Okay. But I think this solution is a CPU architect agnostic. So we have that EXARM export right there. Hardware configuration, right? This platform can be depend on your own You can add 2 GB memory or 4 GB memory, yeah. Even 8 GB memory. Sorry, I cannot hear you very clear. Cost, hardware cost, 3,000 RMB. I got $400 and $500 for $400 or $500. Yeah, I have another platform, just 1 GB memory. Yeah, similar thing. Sometime, okay. Thank you, Aaron. Thank you.